Hi, I'm Jyoti and welcome to my channel. If you're an aspiring pilot, then you're in the right place. I'm creating videos just for you guys. So please subscribe, share, and like my video. It really motivates me to create more content like this. And if you have any questions, any doubts, please comment below so that I can answer all of them.
So let's get started. Meteorology. What really meteorology is? It is the study of atmosphere. It is the science of atmosphere, and it is one of the most important topics to know as a pilot because we are going to fly in that atmosphere. So we need to know what winds are there at that location, what is the weather like, what is the temperature, density, pressure, and where are we flying? Is there any cloud? Is there going to be any turbulence? Is there going to be any thunderstorm, rain, etc., etc.? So we as pilots need to know what the weather is. Now let's understand the composition of air that we've already studied in our previous classes. So composition of air is, air consists of different gases. So there's 78% of nitrogen, then there is 21% of oxygen, and there's 1% of carbon dioxide and other gases which could be water vapor, etc., etc. So what we need to really understand is that our aircraft is not going to be flying at one location. So it is going to go from one location to another. So the temperature, density, pressure, everything is going to change. So for example, today we are flying from Delhi to maybe Mumbai, and my aircraft is going to take off from Delhi and will land in Mumbai, right? Now aircraft will have different instruments that will measure the temperature, pressure, according to which the aircraft would know where the aircraft is flying. The pilot would be indicated, okay, we are at so and so level and all. So if we calibrate the aircraft instruments as per the current location, then it would be very difficult that when the aircraft goes to a different location, right? So if I calibrate all my instruments in this aircraft as per the location in Delhi, then when it lands in Mumbai, the temperature references this aircraft is going to take is Delhi and not from Mumbai. So we need to standardize our instruments in a way so that we have some set standard values. We have some set standard values that we can compare from wherever our aircraft is going to fly to. It could be Delhi, it could be Mumbai, it could be Indore, it could be maybe Srinagar, it could be maybe Chennai. So we need to have set standard values, and from this the introduction comes to the part where we talk about international standard atmosphere. Now before we go to the international standard atmosphere, I want you all to remember these two values, that is your nitrogen by oxygen by volume. So the ratio of nitrogen to oxygen by volume and ratio of nitrogen to oxygen by weight. These are the value, and this is one of the questions that might come in your exam. What is by volume and what is by weight? So volume is basically nothing but something like the space it occupies. So it basically means the space the air occupies. And what is by weight? It is the mass of the air. So remember these values, that is nitrogen to oxygen by volume and by weight, they are different set values. Now we talk about the international standard atmosphere, which is given by ICAO. What is ICAO? International Civil Aviation Organization. So we need to have a standard atmosphere. So is it a real atmosphere? No, it is not. It is a model used for the standardization of your aircraft instruments and to provide reference for temperature, pressure, etc. So there are certain assumptions that we follow when we talk about international standard atmosphere, and these are the values that you will have to remember because there would be numericals based on them. So the first thing that it assumes is that the air is dry. Mean sea level temperature is 15 degrees plus 15 degrees Celsius. Mean sea level pressure is 1013.25 hectopascal, and mean sea level density is 1225 gram per meter cube. So what you need to remember, these are the set values. Now these values are the values on which the aircraft's instruments are calibrated. Now whenever we go to Delhi or we go to Mumbai, so now aircraft is going to compare those values with these values and give us an idea that if the temperature is higher or lower in Delhi as compared to maybe this value, or if the pressure is higher or lower as compared to maybe this value. So now there is a standard value and we can go anywhere and it would be compared as per these values. Now we know that when we go higher, basically in altitude, the temperature falls. So that is known as lapse rate. So there is a lapse rate. So temperature falls or decreases at 1.98 degrees Celsius per 1000 feet, which can be taken as this value for calculation purpose, that is 2 degrees Celsius per 1000 feet or 6.5 degrees Celsius per 1 kilometer. You need to remember the conversions, that is 1 kilometer is equal to 3280 feet, which is fine. So basically your temperature keeps falling up to 11 kilometer. So up to 11 kilometer your temperature keeps falling as we go higher and higher, that is 36,000 feet approximately. Now let's come to the different layers of the atmosphere, and this is very important. So I'm going to create a table and I want you to also remember it like that. So we know now all the values of the ISA, which is your International Standard Atmosphere, which exists on the Earth's surface. So now we are going to write all those values. So we know that the temperature is plus 15 degrees Celsius. We know that the pressure is 1013.25 hectopascal. We know that the density is 1225 gram per meter cube. Now this is the Earth's surface. Now the first layer that comes when we talk about the layers of atmosphere is the troposphere. And troposphere is basically, because of the Earth's gravity, most of your atmosphere consists in the troposphere. There is gravity, so it attracts the atmosphere. So your troposphere has basically consists of 3/4 of the total एटमॉस्फेयर. तो आपका जो भी मोस्टली वेदर है दैट विल बी इन दिस पार्ट ऑफ द एटमॉस्फेयर बाय वेट. ओके, सो दिस इज वेरी इंपॉर्टेंट. सो दिस इज योर ट्रोपोस्फेयर and most of the atmosphere consists here. Now when it is up to 11 kilometers, so it goes up to 11 kilometers. After 11 kilometers there is something called as tropopause. So from 11 to 20 kilometers, up to 20 kilometers, there is tropopause. Now let's talk about that. So let's talk about troposphere. So troposphere, we have a lapse rate, that is every time we are going higher by 1000 feet, there is a fall in temperature by 1.98 degrees Celsius, or you could write it as 6.5 degrees Celsius by 1 kilometer. So up to 11 kilometer the lapse rate is this. Once we reach the tropopause, now this layer has constant temperature. So this layer, when we say constant, we mean that this layer is a isothermal layer. So what is iso? Iso means equal. So whenever we talk about any term which starts with iso, that means equal. So this layer has an equal temperature. So once you reach up to 11 kilometer, your temperature is falling, and then it reaches temperature minus 56.5 degrees Celsius. Once you reach, we'll see how it comes to this value. We will calculate that later in this video. But right now you need to understand that tropopause is the pause in temperature lapse rate. So this layer is basically an isothermal layer where the minimum temperature is minus 56.5 degrees Celsius, and this layer starts from 11 kilometer and goes up to 20 kilometers. So this is your tropopause. After tropopause comes your stratosphere. Now this layer is the stratosphere. Now what happens in stratosphere? There are 2-3 important things. Now there is ozone layer concentration here in this layer. Because of the ozone layer concentration, the temperature starts to rise per 1000 feet. Now the temperature rises per 1000 feet. So this is very important. Now here the temperature starts to increase by plus 0.3 degrees Celsius per 1000 feet or 1 degree Celsius per kilometer. And why does the temperature increase? Because there is a ozone layer concentration which is somewhere 20 to 25 kilometer, between 20 to 25 kilometers there is ozone. Now the second most important thing to remember here is the cloud. So there is one cloud that is known as mother of pearl, or it is also known as nacreous clouds. So this is an important question that might come in the exam, that which kind of cloud exists in stratosphere. After stratosphere there is mesosphere. Now this is also really important because the question that would come in this topic would be again a cloud. So there is a cloud that exists here, that is noctilucent cloud. So this is also an important question. So how to remember is A comes first, O comes after in alphabet. So in stratosphere there is nacreous clouds, and in mesosphere there is noctilucent cloud. So this is about the layers of atmosphere and all the values that you have to remember. So you could take a screenshot of this picture. So basically you need to know very important things is that in atmosphere, troposphere consists 3/4 of the total atmosphere by weight. It goes up to 11 kilometer where the lapse rate is 1.98 degrees Celsius per 1000 feet. After that there is tropopause where there is pause in temperature. So it's an isothermal layer where the minimum temperature is minus 56.5 degrees Celsius from 11 kilometer up to 20 kilometers. Then comes stratosphere where there is ozone layer concentration, because of which the temperature starts to rise, which is 0.3 degrees Celsius per 1000 feet. And there is a type of cloud that exists in stratosphere, that is mother of pearls or nacreous clouds. After that there is mesosphere where there is another cloud that exists, which is very important for the exam point of view, that is noctilucent clouds. So this is very important. Like I said that ISA, that is our international standard atmosphere, it is not a real atmosphere, it is a value set, standard values taken so that your aircraft instruments can be calibrated according to that. So the atmosphere is definitely not going to be the same, it is going to be different, the temperature is going to be different, the lapse rate on a particular day would be different as compared. So very important thing that comes in your questions is basically the height of your tropopause. So in this atmosphere that we are talking about, when we talk about ISA, so if this is my first half, like the northern half of my, we'll take this as equator and this is as pole. So basically my troposphere, as per the ISA, that is our international standard atmosphere, it is equal at all lengths. So this is also 11 kilometer as per ISA. This is also 11 kilometer as per ISA. And this is also 11 kilometer as per ISA. But in real life, it's not the case. In real life, the troposphere is different at different points. Why? So for example, this is the real earth. For example, if I'll take this as equator, please pardon me with the diagrams that I'm making. So this is the equator. In real life, what happens is, if this is the pole, so this is how my troposphere looks like. So it is approximately 8 kilometers near the poles, and it starts after 16 kilometers from the equator, and the average at maybe 45 degrees, you could say, that is 11 kilometers, which has been taken by the value by the ISA. This is the ISA value. So why is it different? Because the temperatures are different, the density is different. So it is hotter near the equator and very cold near the poles. So the air, when it is cold, it is heavy, so it settles down. So the troposphere consists most of your aircraft, so it settles down, and tropopause starts right after 8 kilometers. Whereas in equator the temperature is higher, so the air is not as settled as compared to the near to the poles. So here the tropopause starts after 16 kilometers. So this is again a question in exam, that what are the different kilometers or the distance after which the tropopause start in real atmosphere. So now let's see how at tropopause minus 56.5 degrees Celsius comes. So let's make a graph. So here there's mean sea level, I'm taking temperature which is 15 degrees Celsius. Let's take every altitude, that is basically 1000 plus 1000 plus 1000 on the y-axis. Now let's say if this is 1000 feet, so every time we are going higher by 1000, our temperature would be 15 degrees minus 2 degrees Celsius, right, per 1000 feet is equal to 13 degrees Celsius. When we go at 2000 feet, now it would be 13 minus 2 degrees, which would be 11 degrees Celsius. So now we go to 3000 feet and so on. 11 degrees Celsius minus 2 degrees Celsius is equal to 9 degrees. Every time we are going 1000 feet higher, our temperature is falling by 2 degrees Celsius. So this is how it would be, right? So it will keep on falling. It will come like the graph would be made like this. So first was 15, then it was 13, then it was maybe 11, and then it was 9, and so on. So now this is very important to understand. So with this there comes a formula, that is, so ISA, very important, please write that down. ISA temperature at given altitude is equal to 15 minus whatever altitude that you are flying at upon 1000 into 2. So this is very important. Let's see how this would help us understand that. Now we know that our tropopause was from what, 11 kilometers to 20 kilometers. 11 kilometers was somewhere close to 36,000 feet, and when we talk about 20 kilometers, it is approximately, you would say, 65,000 feet. You can calculate that, it's approx value. So now let's calculate here. So this exact value is basically 36090 feet. Now let's put this in this value. At 36090 feet will be equal to 15 minus, what is the feet? 36090 upon 1000 into 1.98. I am taking the exact value as of now. So that will be 15 minus, open your calculators and see what is the value that is coming, into 1.98, which would be equal to 15 minus 71.45, which is equal to minus 56.45 degrees Celsius, which is almost 56.5 degrees Celsius. So at 11 kilometer, or you could say 36090 feet, our temperature is falling and falling, and this is the value that it's reached. So now let me give you a few questions as homework so that you can do them and practice them at home, and you can let me know the answers in the comment section. So question number 1 is, find ISA temperature at 15,000 feet, at 25,000 feet, and at 45,000 feet. And while doing these questions, do remember that the lowest temperature could only be minus 56.5 degrees Celsius. If your temperature is coming out to be minus 60 or minus 70, that cannot exist, because up to tropopause it is minus 56.5 degrees Celsius. After that, the temperature is constant in the entire tropopause layer, and then in stratosphere it starts to rise again. So the lowest is this temperature. In real life it can be lower, but as per the ISA calculation it cannot go below this temperature. So while calculating this, remember this lowest temperature. Now let's come to the next part. Now the last part of this topic is deviation calculation. Deviation calculation. Now why is important to calculate the deviation? So now ISA is not the real atmosphere. ISA is a standard atmosphere that is created by ICAO. So it really helps in basically standardizing the aircraft instruments in a way so that we can compare different temperatures at different location. So why deviation is important? We need to know in reality what is being in that atmosphere at that time. So for example, if I'm today taking off from Delhi, so I need to know what is the temperature at Delhi, I need to know what is the pressure at Delhi, I need to know what is the density, because why I need to know, it is all going to affect my aircraft performance. How? So if, for example, today the temperature is higher than the normal temperature, so my air would be less dense because it's denser when it's colder. So my air would be less dense. So when my aircraft has to take off, the less dense air would affect my aircraft performance because the thrust produced now would be lower, right? So this is why it is important to know what is the deviation. So how do we calculate deviation? Now again, a very important formula. So deviation is equal to your actual that is existing today minus your ISA values. That is how you calculate your deviation. So we'll solve a question so that you understand better. So for example, on a particular day, your mean sea level is temperature is 20 degrees Celsius. Now calculate the deviation. So we know that today the actual temperature is 20 degrees Celsius, and we know that the ISA temperature at mean sea level is 15 degrees Celsius. So now we'll put it in the formula. So deviation is equal to actual, that is 20 degrees Celsius, minus plus 15 degrees Celsius, which is your ISA, comes out to be plus 5 degrees Celsius. So the deviation today is plus 5. So our temperature is 5 degrees warmer than 5 degrees warmer then ISA. That is how you calculate. The same way you can calculate the deviation for pressure as well. So now let me give you maybe homework that you could practice at your own pace at your home, and let me know the answers in the comment section. So the question would be that actual temperature at 6 kilometer. Now I am not taking it in the feet, I am taking in kilometer. So remember the calculation is minus 45 degrees Celsius. Find the ISA deviation. So try solving that. And the next question that you can do is the temperature at flight level 70 is 3 degrees Celsius. At what altitude will the temperature be equal to 11 degrees Celsius? Next, the actual temperature at 14 kilometer is minus 62 degrees Celsius. Find the ISA deviation. Do these questions and let me know in the comment section. So these are the questions from IC Joshi, very important for the exam point of view. So please attempt all these questions and let me know if you have any doubts in the comment section.
Thank you so much for watching. If you really like my video, please do not forget to share, like, and subscribe. It really helps me and motivates me to create more such videos for you all.